Hi friends, welcome to my YouTube channel Victory Academy. This is Venkatesh. Today we are going to start a new coding series in which we are going to discuss coding problems which might be helpful in interviews. Let's start coding. The first problem of the day is a two-sum problem in a lead code. Let's start exploring the description of the problem. There will be an array of integers and an integer target where we need to return the indices of two numbers such that they add up to the target. So here we also might need to assume that for each input array there might be only one solution, and we can return the solution in any order possible. So let's start exploring the example as well. So if we consider example 1, we will be having an integer array of 2, 7, 11 and 15 and a target of 9. Here it's an easy thing, we can reduce that. 2 plus 7 is equal to the target, which is 9. So we have to return the indices as 0 comma 1 since indexing starts from 0 in lists. So the output should be 0 comma 1. Similarly, if you explore the other example 3 to 4 and the target is a 6, the sum of 2 comma 4 will be the target where we need to return the indices 1 comma 2. So, and there is a time constraint as well, which is order of n square. So let's start writing a solution for this problem. In a lead code, we already have an interface where the function is already defined. We just need to write the logic over here to get the code to be run. So let's create a dictionary to store the values in it and create a for loop to iterate over the list. So we will be using enumerate function to get the indices as well. The main functionality of the enumerate function is to iterate over the list and store index values and the element values of the list. So now we will be subtracting every element of the list from the target value and assigning it to a variable called n, and we will be checking if n exists in the list or not. If n exists in the list, then there is a key value pair in the list whose sum would result in the target. If not, there are no such key value pairs in the list whose sum would result in the target. So this can also be achieved using a dictionary where the elements will be stored in the key value format, where keys represents the element value and values represents the index value of the respective element. So now we will be checking in the implementing that format. So let's start doing that. So where n is equal to target minus sum, so every element will be subtracted from the target and stored in an variable called n. If n exists in the dictionary, then if n doesn't exist in the dictionary, that means there is no no such key value pairs as of now in the dictionary. So let's try to add it to the dictionary. So h of num is equal to I, where num represents the element and I represents the index of that respective element. Or else if we do have the element in the dictionary, then that means there is already an existing key value pair in the dictionary and existing value pair in the dictionary whose sum would result in the respective given target. So now in that case we will be returning h of n comma I, where h of n stands for already existed index value for the respective element and I represents the currently passed index value of the positive output. Let's try running it. So here we can see every case is been passed and it's an optimal solution. So let's try submitting it as well. So when we try to submit, we will be getting an runtime of 41 milliseconds and memory of 17.7 MB. MB. So that is a very optimal approach which we have currently deduced, and that will help in our that will help our code. So yeah, this is the first code of our coding series, and thank you, and signing off, Venkatesh.